Today's webinar is learning to build a resilient video surveillance and storage solution, or how to meet the increasing demand for no single point of failure surveillance. We're starting to today see more and more specifications that require no single point of failure within the entire subsystem. Sometimes it's relegated to just no single point of failure or high availability within the storage subsystem. We're going to cover soup to nuts and show you how it lays out, things that you have to consider along the way. Additionally, for the end users, think about this. For the resellers that are attending, if things aren't mentioned as part of the specification, please use some of this information to question the specification. There's a lot of times there's ambiguity in what the spec says versus what they really want to accomplish. Okay, before we get into servers and storage, right? Uninterruptible power. Get it. It should always be planned for. The reality is the majority of system failures or downtime throughout the United States, or for that matter the world, is due to loss of power. In the United States, the average business loses power 8 times a year with an average outage of 27 minutes. Right? The other thing that uninterruptible power supplies protect you from are brownouts, low power, not power being gone, and power spikes. Both of these cause damage to the systems. Particularly power spikes tend to put a little bit of wear on the power supplies and shortens their overall life. If you have questions about what your power history is like, your local power companies are required by law to keep track of and have reports available for their outages and their durations and so forth. They can even, if you really wanted to drill down, give you specifics within towns, for instance, or cities, and segments or areas within a city. When you're sizing your uninterruptible power supplies, determine what is the maximum downtime that they can incur. A lot of sites on the larger sites have a contingency plan where if they're going to lose power for longer than X, then they'll actually bring in physical guards or people to man certain stations or perimeter stations, key locations within buildings and so forth to maintain some kind of surveillance and security. And the other thing is list the most critical areas of surveillance. Excuse me. A site might have 45 cameras, and the reality is they need to maintain surveillance in the most critical areas would only be 8 cameras. So you can disperse UPSs as required to make the critical application rather than normal operations. Let's see. The other thing is all UPSs are not created equal. So when you're selecting your UPS system, make sure that it's got software that runs within the NVR. And the other thing that's critical is the connection. A lot of the new systems have USB connections only. Your system might, or your storage array, or your server might only be able to accept network notification or serial port notification. So double check. One, that the software is compatible, or there's an alternate software package that the vendor can supply that will run across storage and servers, and that you have the right connection types in order for it to all fit into a heterogeneous environment. Next, always plan a little bit ahead for battery life. A new battery is what the specification's written for, and that would reflect your uptime based on how much power you draw. Batteries aren't quite as efficient and don't have the same poop, I guess is the way I'd put it, after they've been sitting there for a year or two. So fudge in a factor for decreased battery efficiencies. And use multiple units and sizes as you deem appropriate within the confines of your surveillance solution. And anytime that you get beyond these 30-minute to 2-hour, 3-hour hold-up times, which is a typical sizing for a UPS, motor generators become more of a requirement than a simple UPS would be. So within a lot of facilities, you'll find that they do already have motor generators. The question is, how fast do they kick in? Will that kick-in time and that delay cause problems with your servers rebooting, your storage rebooting? So if you're questioning and you're working with a prospect in a situation, or you're designing a specification, do examine how the motor generators will take over and what the switchover time is and so forth.